And as I said, we're going to review our exponent rules first. So, if we look at the product rule, when I am multiplying powers that have the same base, what do I do with their exponents?
Add them together?
Well, let's show why we add them. This means x times x times x, that's x cubed, times x, giving us how many x's? So we add the exponents when we multiply powers with the same base. Then what do we do when we divide powers with the same base? We do, let's show the work, x times x, divided by x times x, and we get some canceling that happens, and we are left with x to the first, which is the same as x to the 3 minus 2. Wait, x is third, or x is second. Well, I'm just showing that it's subtraction. Okay? And this x to the fifth comes from x to the 3 plus 2. I know you don't have to write it that way, we're just showing the operation that happens. Okay? All right, so that is product and quotient. So what about power rule? If I have x cubed squared, well, that means that I have x cubed, which is x times x, squared means I multiply it by itself, correct?
Yeah.
Which means x times x times x, giving me how many x's? X to the fifth. So when we have a power raised to a power, what do we do with them?
Multiply.
We multiply them. Okay? All right, reminders on the right side. When we have xy in parentheses to the fifth, we need to remember that fifth applies to everything that's in the parentheses. And notice this is multiplication that I'm talking about here. Addition is something that we do slightly differently. But as long as there's multiplication in there, we raise x to the fifth and y to the fifth. Our next one, put a star next to this, probably the second most common error that happens with exponents is when we have x to a negative power. I don't know if you can tell me that's negative, but there's a negative there. X to the negative 4. Anybody remember what that means?
Yeah.
Does not put a negative in front. X to the negative 4 is the same as, well, 1 over x to the positive 4. And then finally, just like our property 2 up from where we are now, x divided by y to the fifth, with division, the power gets applied to both the top and the bottom. So that's the same as x to the fifth over y to the fifth. All of these exponent rules are pretty simple on their own, but it's when you get a big mixed problem that they end up getting a little tricky. So we just need to keep straight how they work on their own and then apply them individually when we have a mixed problem. All right, any questions on these? Okay, so these are the review of our exponent rules. Next, I'll just close it. Okay, that's up here. So our new rule, which you may or may not have seen in the past, you do not need to write what I have over here, but I want to talk through it because people never remember why this works the way it does. So here is an explanation of how rational exponents and radical expressions are tied together. So rational exponents means we have a fraction in the exponent. Okay, and a radical expression is one that has either a square root, or a cube root, or a fifth root. Okay, so when you see radical expressions, we're talking about the roots. When you see rational exponents, that means we have fractions in the exponent. All right, so over here we have the fourth root of a cubed is equal to a to some power, and we're trying to find out what x is, what that power is. You don't have to write this part. Just watch All right, well, if the fourth root of this equals a to the x, then to undo the fourth root, we would raise both sides to the fourth power, correct? To undo the fourth root? That would undo the fourth root. We have a cubed over here, and here we would have a to the x to the fourth power, or a to the x times a to the x times a to the x times a to the x. So, on the left we now have a to the third, and on the right we have a to the 4x. Well, if their bases are the same, then their exponents are also the same, so that means 3 equals 4x. We solve for x, and x is 3/4. So that means that the fourth root of a cubed is the same as a to the 3/4. So now, this is the part that needs to go in your notes. Big cloud, and what's under the big cloud. We're taking the fifth root of x cubed, a number that is higher up in the actual equation. Notice the 3 is higher. It stays on top of the fraction. So when we want to write this as an expression with fractional exponents, the 3 is higher up, so that stays on the top of the fraction. The 5, the root, is lower down, so that's the bottom of the fraction. So the bottom is the root, the top is the power. The other way you may see this written, if you see the fifth root of x cubed, that is the same as the fifth root of x, finding that first, and then cubing it. This is the same thing. And sometimes it makes it easier to solve a problem if you write it this way. So make sure to get these down. All right. So, for example, what is the simplest form of this problem? Well, we're dividing powers with the same base, the base of x. So let's write these as rational exponents first. So this top would be x to what power? X to the
3/4.
3/4. Over the bottom. X to the
1/4.
2/8, so I'm going to write first, and that is 1/4. So we have x to the 3/4 over x to the 1/4. And what do we do when we divide powers of the same base?
Subtract.
Subtract. So this is x to the 3/4 minus 1/4, or x to the 2/4. 1/2. That is an acceptable answer. What if I asked you to put the answer in root form?
Root x.
So it is the square root of x to the first, correct? So you could write it like that. You could leave the first power off because you don't generally write that, so the square root of x would be fine. So depending on how you're asked to give the answer, rational exponents or roots, it would either be this one or one of these. Okay, questions here?
No.
All right, let's look at another one. Okay, so on this one, what is each number in simplest form? Again, we're asked to write it in simplest form. Well, decimals are actually harder to work with exponents than fractions. So how do I write negative 2.5 as a fraction? 16 to the negative 1 over 2 equals 2.5.
5/2.
5/2. All right, what does the negative in the exponent do? 1 over. And let's write it as a root in the bottom. Well, I'll start with 16 to the 5/2. And then if they said to write it in root form, will be 1 over what?
5.
What's the root?
16.
Square root, so root 16 to the 5th power. What is the square root of 16?
4.
4. So we have 1 over the square root is 1 now. We take the square root of 16 to get 4. 1 over 4 to the 5th. That would be the okay. Write yourself a little note on this page. If there is a negative exponent in your answer, you're not simplified yet. Negative exponent. In your answer, you are not simplified yet. All right. Let's try this one. This is our last example. What are these numbers in simplest form? So, we have in parentheses negative 32 to the 4/5. Let's write it in root form. That means we have negative 32 inside what root?
4.
Bottom is the root. So that is a 5th root to the 4th power. The 5th root of negative 32. Here's where you want to write yourself a note. Your calculator, I think it's math 5. I'm going to look for it. Yes, math 5 allows you to do whatever root you want on the number. So here we would put 5 for the 5th root, and then press math 5, and then plug in negative 32. What is the 5th root of negative 32? Negative 2. So this is negative 2 to the 4th. Anytime you're dealing with negatives, keep them in parentheses. What is negative 2 to the 4th? Positive 15. Keep the negative in the parentheses and then raise it to the 4th. So that should be positive 15. Okay? So you're going to be doing homework problems that mix all of these rules together. I will finish this video with these 2 examples, so if you're stuck on homework, come back to the video and look at that. The homework is section 6.4. Numbers 11 through 65, every other up. On the page. Page 386.
Here are our final 2 examples worked out. We apply the 2/3 power to the negative 8 and to the x to the 1/2 and the y to the 1/2. Negative 8 to the 2/3 means the cube root of negative 8 squared. Cube root of negative 8 is negative 2. Squared is 4. And here we multiply the exponents. 1/2 times 2/3 is 1/3. So we get x to the 1/3, y to the 1/3, which we can put under 1 cube root. So we get 4 cube root xy. Here we apply the negative 3/4 exponent to the 16 as well as the y to the negative 8. 16 to the negative 3/4, we take the 4th root of 16 to the negative 3 power. That's 2 to the negative 3, which means 1 over 2 cubed. The y to the negative 8 raised to the negative 3/4, we multiply the exponents to get y to the 6th, and we end up with y to the 6th over 8.